Welcome everyone, and thank you for joining this webinar. Today's presentation is all about custom products. My name is Eric Rice, and I will be your moderator for the next 30 minutes or so. A quick note about this webinar series. This webinar is part of a series that started back in April and will end this month with our final presentation on July 23rd, in a couple of weeks. The presentations being made in these webinars cover a variety of topics related to motion control, and they always spotlight our motor and drive products in them. All of the webinars in this series are being recorded, and those recordings are being made available for watching on demand. Recordings usually go up within a day or so of the live event, and you can find those recordings on our website. There are links on the homepage and in the news section of the website. You can also find the recordings on our YouTube channel. There's a playlist there called Webinars where you'll find all of the recordings from this series, as well as past webinars that are not part of this series. Regarding questions for today's presentation, there will be time at the end to answer your questions. Please submit your questions using the webinar control panel. And any questions we don't get to during the Q&A will be followed up via email afterwards. So without further ado, let me introduce today's presenter. Jeff Kordick has been designing step and servo motors and the electronics and software to control them for over 30 years. He serves as the Chief Technology Officer at Applied Motion, where he leads our engineering team on their passionate quest to provide the motion control industry's most innovative and connected products. Jeff holds a master's degree in electrical and computer engineering from the University of California, Santa Barbara, and a bachelor's degree from the University of California, Santa Cruz. He is a longtime resident of California's scenic Monterey Bay. And with that, I will turn everything over to Jeff for the presentation. Jeff, it is all yours.
Okay, thanks, Eric. Let's get started. So what we're going to talk about today are custom products, because about a third of everything Applied Motion sells is customized in some way. Even though we have a broad and deep standard product offering, many applications require something a bit bespoke, and that's one of our specialties. As an example, private label. Our product becomes your product. A lot of companies have a reason to remarket something and not have to design and produce it in-house or redistribute it. So we can do software and label designs that look like it's your product, not ours. We can apply this to motors, integrated motors, drive electronics, and software. And one of the things that allows us to do this quickly is we have software and graphic designers, mechanical and electrical engineers right here in California that can jump on this stuff. Special packaging is another area where we do standards. On the right, you'll see a typical drive that could ship to you individually packed. The drive is in the red bubble pack, but what you also get are your mating connectors, a quick setup guide, a handsome Applied Motion screwdriver that is used for tightening the screws on those connectors. And of course, if it's a programmable or configurable product, you get a configuration cable. Not everybody needs all that stuff. A lot of OEMs who buy in volume will make their own cable harnesses ahead of time. They would just be throwing those mating connectors away. They might ask us to leave them out of the box. How many Applied Motion screwdrivers do you use? Well, there's a limited number that anyone wants of those. Same with a quick setup guide. You've read it once, you've read it. So we can accommodate people, and the way we do this is we take out a custom part number for you. You order on that part number, and we have documentation in-house that says, okay, what does this customer actually want? We do a lot of mechanical customization. We have a well-equipped machine shop right here in California with lathes, grinders, CNC mill, and we can do rapid prototyping. And at our offshore facility where all the volume is done, Shafts are produced on these Swiss screw machines that can be easily reconfigured to add flats and steps and screw features, tapped holes, you name it. Shown here on this screen, we have an integrated step servo motor. So that's a NEMA 11 high torque step motor with electronics and controller right on the back. And in this case, what we have done is we've used a hollow shaft. So there's a big hole all the way through the motor on this thing. And our customer can then add their own shaft or lead screw. And if they maybe need different lead screw pitches for different axes on an application, they buy one motor and they apply different screw pitches to it. On the right is the same concept with at a motor only level. So there's a size 17 and a size 23, again with precision holes through the shaft that you can add your own shaft to. On the left, we have another mechanical customization. The rear shaft on this motor has both a tapped hole and a pin through it. And this motor has a connector. This looks like a Tyco MTA style connector that we provide for plugging directly into the customer's electronics. And we have ability to do lead screws and ball screws as well in volume. And this is a completely integrated step servo motor with a precision ball screw on it. And in fact, I should say our next webinar, the one Eric mentioned on July 23, we are going to cover all the details of our linear products, because in addition to screw motors, we actually make linear actuators where the carriage and the linear bearings and everything are included, which can take a lot of work off the mechanical side of our customers. So here we have a step motor with a worm gear. We also have a motor with a Molex connector on it. Whatever you need, we can accommodate. Again, short runs here in California, and volume we bring in from our main factory. Here we have a step motor with a holding brake. And what that allows you to do, if you have a gravitational force that might move the motor after you power it down, and that's unacceptable, we can put a holding brake on the back. So when you remove power from that brake, it will automatically, through spring force, hold the motor shaft in position. We do those on size 17. We have a standard line of 23s that even has a housing over the brake. On the right is a very interesting mechanical and environmental customization. This is the power steering motor for self-driving car. And it's actually a brushless DC motor. It's rated actually better than IP65. The requirement is you're under the hood of a car, there's going to be some water and mud splashing around. So the spec is under 1 meter of water operating for 30 minutes. So this, again, exceeds really IP65 ratings. You'll notice the laminations have an extra seal coating on them. There are gaskets between the motor end bells and the stator. And there's a cable gland and a shielded cable coming out of this thing. So that's all sealed tight too. There's a shaft seal on the front. And in this case, rather than just bringing out the standard round shaft, we have a short shaft with a flat and a tapped hole into it, and that's what actually ties into the rack and pinion steering on this vehicle. We put motors. We put encoders on motors. Most of our motors come, the double shaft ones at least, with standard tapped holes in the back for common encoders. You can put your own on, or we can do that convenience for you. This is a fully custom drive. It was a very interesting application where the customer needed lots of axes on a machine, and they wanted to centralize the control aspects of this. We initially started working with them on integrated motors so they would have distributed control all over their machine. And in the end, they chose to do a custom electronic board and just use an off-the-shelf step motor. So what we did here is we stepped and repeated an existing design that we had. so that you get 8 axes on one board. To manage it thermally, we put all the heat producing components on the bottom, and then there's an aluminum heat plate that this whole board is mounted to, and that goes into the customer's machine to pull heat out of the drive and manage the thermal aspects of the application. And this particular application uses RS-485 as the communication, and the protocol is our own serial command language. So they're streaming commands out to as many as 32 axes at a time. And the way that's accomplished electrically is you have a DB9 connector at each end of this, a male and a female. One end of this goes to the host controller. The other one can go out to successive drive boards that are chained together. There's a 32-axis typical limit for RS-485 just because that's how much load a typical drive IC can handle. So we've limited this scheme to 32 axes. You set the base address of each of these boards. For example, if you set it at 1, these axes will automatically self-address as 1 through 8. You would set the next one in the chain as 9, so you would get 9 through 16, and so forth. You can also adjust the bit rate on these. So that allows one customer to have a simple solution with a lot of axes all in one place that would be easy to service if anything happens on this machine. Here's another custom drive and controller. We had a customer who was making a peristaltic pump. It's very common to drive those with step motors because step motors have positive displacement, and so does the peristaltic. And for medical applications, you can remove the tubing. The motor, the pump essentially does not see any fluids. It's all contained within tubing that can be removed and replaced. So this customer was just buying from us the step motor you see on the left, and we happened to be there in a courtesy call, and their CTO said, you know, we wished our homemade drive board works as well as your motor, because your motor never fails, and we get about a 50% yield on this in-house design drive. You guys do a lot of drives. What can you do for us? So what we ended up doing in the end, the most cost-effective approach we could find is we did a board that controls their pump. So it has inputs from membrane switches, it has an input from a rotational sensor, and outputs to drive LEDs that give the surgeon operating this pump positive feedback on what mode it's in. We ended up using an off-the-shelf driver. Why? Because we make tens of thousands of these things, and we've really got the cost controlled on these and the quality. So what we actually supply to these folks is the motor they always bought, an off-the-shelf drive, and a very bespoke control unit. The hardest part of this actually ended up being the quality standards. So anything FDA controlled has very exacting quality standards that are reflected through your whole design, production, and quality system. So we spent many days getting audited and many weeks of catching up on documentation to satisfy the FDA. But that's the kind of stuff we do for custom applications that sets us apart from our competitors. This is a mechanical thermal customization. This is our new MDX integrated servo motor, and these are available in a 200 watt and a 400 watt 60 millimeter standard metric mount. The electronics and control all built in. All different manner of field bus and streaming commands can be fed into these. So we designed this unit to do 200 watts continuous with the electronics built in, or 400 watts. So we needed a decent amount of heat sinking here because you got a motor producing heat, you've got electronics producing heat. But we ran into an application for a gate opener on a subway, and those have a very high peak power as they're swinging the gate open and then closing it again, but then it can sit for seconds or even minutes idling at no current. So because the space is very limited, you know, when you're doing like gates to a subway or an amusement park ride or something, you want to get as many in as parallel as you can. So the electronics that sits between the two gates, there's always a drive to make that as narrow as you can. So the long heat sink was just too much. What did we do? We tooled up a shorter one. For the short, fast moves and the modest average power, it worked out fine, and we were able to win this business. This application was for a packaging machine that does bagging, and it can accommodate quite a wide range of bag sizes. And as a result, they need different recipes built into the control so that the speeds, the accelerations, and the current can all automatically adapt when a new bag size is introduced. You don't want to call somebody out and have them reprogram the whole thing. This particular application uses a field bus called Ethernet IP. We offer many products with Ethernet IP, as well as add-on instructions and lots of app notes and sample code to make your job easy. Well, what these guys needed was something a little different than our standard. They were going to go the distributed intelligent route, where you write a program in our Q language, you put it in the driver, and then you actuate these different Q segments real time over the Ethernet IP field bus. But the way our Q segments work over the output assembly is you trigger the thing and then it just goes off and does whatever's in it. So these guys wanted the recipe to completely reconfigure instantaneously anytime you trigger a Q segment, which means we have to pull the P current, the constant current, the speed, XL, VCL distance, all of that out of the input assembly in real time before we launched the Q segment. So we were able to make this happen for these guys and win this business because nobody else could react that quickly to custom Ethernet IP functionality. But we do all this stuff in-house. We have experts ready to go when this kind of application comes along. Moving to the other end of the spectrum, what I guess we could gracefully call dumb drives. We sell lots of step and direction drives. Our STR line is very popular. And the way these work is they accept step and direction signals from a host controller, like a PLC, and or like a Galil controller, that kind of thing. So these don't require any kind of software or any kind of configuration cable. It's all done through switches, dip switches, rotary switches, and we bake as much functionality into these as we can. A wide range of applied motion motor sizes. You could set the steps per rev. You might get 8 or 16 choices. You can even set things up like smoothing filters to make full step work more like micro step. You'd think anything anybody could ever want would be in there, but not always. So we often get customers who come along and say, hey, I need a little different steps per rev setting because that's what our application requires. Or we have to use a different specialty motor. The load inertia, you might want to tweak the load inertia, the anti-resonance parameters if you're using a non-applied motion motor. So we could customize all of that stuff because all of these drives have a configuration stored in non-volatile memory that we put there. So if there's anything different that a customer needs, we can do that quickly and easily. Again, we define a custom part number, and then we have documentation and a database table in our drive production line that can shoot whatever we need into your product right before we ship it. Also, all these switch settings, we can set those for you so that when you buy a unit, it's ready to go right in your machine. So these are common ways we do customization on inexpensive dumb drives. So in addition to setting switches, let's switch back to smart drives for a minute. So what we can do on smart drives is essentially the software equivalent of setting the switches. On our production line, we can shoot over serial or Ethernet communication the configuration you want. If it's a servo, we can set up your servo tuning parameters. And if you have a Q program you've written, give it to us. We'd be happy to put it in the drive for you. So you pull the drive out of the box and maybe you set an address switch through the rotary switch. So each axis has a unique address. The rest of it can just be ready to go and save you a lot of labor. Frozen firmware. I mentioned the FDA earlier. So many, if not all, FDA-approved medical products require fully validated firmware and software. The FDA rightfully pays a lot of attention to software and firmware because of stuff that's happened. And once your product is approved for release, if you change the firmware revision level or any component, you're going to have to go back and revalidate and recertify. Nobody wants to do that unless there's a very good reason, like you're upping the performance or something. So we offer medical customers products with custom firmware. We take out a custom part number. They order on that part number. We automatically put in the firmware that was validated for them. Another interesting application we had on the field bus side of things is we provide a lot of products that have the old Modbus standard, which is still one of the most widely used field buses in the world because just about everything, every controller has Modbus in it, and most drive electronics, certainly almost all of ours, can accept Modbus commands. But in the Modbus standard, they discuss how a packet gets assembled, how the addressing and CRC are done, and how you send a certain amount of data to a certain register or bank of registers. What they don't tell you is what has to be in those registers. For example, one of the first Modbus registers you can typically write to is 40001. But on our product, that might be the motor current, and somebody else's, it might be the speed. So you can't just grab a product, plug it in, and think that your existing PLC programming is going to work. So we had a large OEM that came to us. They make a piece of industrial scale HVAC equipment, the kind of thing that provides air conditioning in an office building or a hotel or a factory, maybe an airport. So they were buying a smart actuator that had gone out of production. The vendor was just not interested in making it anymore. So they came to us and said, look, it seems like something you guys could probably do. If you could duplicate the mechanics of this closely enough, it's one other thing we'll need. We're not really in a position to reprogram our PLC panel, so we need you to match the other guy's Modbus register map, which turned out not to be a terribly difficult thing. And again, we have in-house people who do that stuff. Probably a bigger challenge on this is they said, look, we will need you to validate your solution, but we're not going to roll a truck up at your place with one of these giant HVAC units on it, nor is it really practical for us to take the touch panel controller out of that, because once you remove it from the machine, it's really not going to do anything. So we also had to develop a simulator for this system so that we could validate in-house before we started shipping product. And again, that's the kind of stuff our engineering team here could do. Here's a similar application that's made for harsh environments. In this case, we have a customer who makes conveyor lines. Imagine a factory making bottles of beer. At some point, those get packed into a 6-pack or a 12-pack. That goes down the line. It ends up putting on a pallet. There's a lot of axes of motion involved in that whole process. And we have a customer who uses as many as 100 of our smart motors on each custom conveyor system they do. Well, because all this stuff has to be washed now, remember we're talking about beer here, right? Something could get wet. And if a bottle of beer breaks, you sure don't want to have to go replace all your motors and electronics. So everything's washed down. It all uses sealed metric circular connectors, in this case M12. Those connectors are expensive enough to begin with, but when you start buying long cord sets to connect them together, it can run into some serious money. So there's two ways we solve this expense problem for our customer. The first is dual port Ethernet. So originally, when we started doing business, our stuff was single port. Now you're running very long, expensive cables back to a control cabinet that's stuffed with a rack of Ethernet switches. So a lot of money there. So we built an Ethernet chip into this product that's now standard on many of our products. So there are two Ethernet connectors behind those. There's a smart Ethernet switch that routes the packets. So you just connect all the drives together in a line. So now instead of every drive going all the way back to a control cabinet somewhere. It just goes to the nearest drive and then on from there. And then one drive actually connects to the controller. So yeah, that saves a bundle by shortening the cables and eliminating all those Ethernet switches that would be in the control cabinet. Also the I/O. We pack as much I/O into our products as possible because if you don't have enough, you can't get the business. If you have too much, it's okay. Well, it wasn't really okay to these guys because these 12-pin I/O cables can really add up. So since they only need one input and one output, we customized this product to have a 4-pin I/O connector, which again, it makes the product less expensive for us to manufacture, and it makes the mating cord sets a lot less expensive. So now the customer doesn't pay for anything they don't need. Extended temperature range. We do a fair amount of business in mining, oil and gas, and cell towers. There's a lot of cell tower business right now because everybody's getting ready to go 5G. So a lot of stuff's going to get replaced. That stuff has to operate all over the world. In the Arctic, northern Alaska, all the way into West Texas oil fields or the sands of Saudi Arabia. So we have developed an expertise in developing motors and electronics that can handle a extended temperature range. Low EMI is another application we run into from time to time. All of our products are CE rated, so they do have to meet emission standards, but not all applications are created equal. So we run into some where, excuse me, you need the lowest EMI that is possible, which is difficult to do when all modern drives gain their efficiency and performance through PWM. We are switching the motor wires at 20 kilohertz and up to as much as 10 amps, depending on your motor. You can create, even with a shielded cable, a decent amount of EMI doing that. So we have techniques that we can apply that will reduce the EMI for your application. So other than our vast high-tech customization capability, why would one choose to do business with Applied Motion? Well, we have a lot to customize, or not customize if you find something standard off the shelf in our product line. We have NEMA motors from, this is actually a typo, 8 to 34 now. And we've recently even introduced a size 56 motor. That's our oil and gas motor, completely explosion-proof, certified for hazardous locations worldwide. You can get anywhere from now 4 to 1,100 inch-ounces running torque. We make integrated motors. If you want the electronics on the motor for simplicity and to reduce the wiring, great. If you are more comfortable with a separate motor and drive, we've got that too. We handle environmental considerations like IP65, water and dust proof. Most of our products are programmable through our key programming, so you can actually customize their behavior yourself and take a load off your central controller. We do lots of field bus, Modbus, CAN Open, Profinet, Ethernet IP, EtherCAT, you name it, we got it. And we also stock accessories that can help you get up and running quickly, like all the mating cables you would need. If you need a USB serial converter, all of that stuff is good to go. We also have stellar pre and post application support. We have an experienced nationwide team of sales and application engineers. So if you run into any trouble or if you have any inquiries, pre-sales, post-sales, we've got people on the line to handle it. And I'll just show you where some of our locations are. This gold star is Watsonville, California. It's on the Monterey Bay in Central California, about 40 minutes from Silicon Valley and 90 minutes from San Francisco. We have sales offices in Seattle, San Diego, Waco, Texas, Kansas City, Chicago. We are now open in Charlotte, North Carolina, as well as Boston and Rochester, New York. So we have people in your time zone if you need their help. So Eric made a plug earlier for our Smart Actuator webinar series. If you have an interest in linear motion, please sign up for that. It will be coming up in 2 weeks. So Eric, I'm going to hand this back to you for the Q&A.
Thanks, Jeff. That was great. That's right. We're in the question and answer time. Jeff, a few questions have come in, so I'll get started with those. But first, as a reminder to everyone listening in, if you'd like to submit a question, you can do that in the webinar control panel. So one of the first questions that came in, I think this is one of your early slides, Jeff, was on hollow shaft motors. Can hollow shaft motors have an encoder?
Yes, they can. There are some restrictions on that because we have to get an encoder with a big enough bore because there's still really a shaft. A hollow shaft means a shaft with nothing in it. I'm going to scroll back here a little bit. But yes, you can definitely have an encoder. In fact, this one on the left here, this is a size 11 step servo motor. Well, step servo motors have to have encoders. You can't close the velocity and position loop without it. So yeah, we have got an encoder on the back of this. In this case, the bore is blind, so it does not go all the way through the unit. Which is actually kind of good because you drop your shaft in until it stops at the bottom of the bore, and you're done. You just have to then laser weld it or glue it in.
Okay. Cool. Yeah, that was something I wasn't quite sure on, is whether it was blind or through. But that makes sense.
Yeah, we can do both, actually. But yeah, if you need an encoder, you're better off blind.
Got it. Okay, another question came in. This one has to do with the flats on the shafts of step motors and step servo motors. This question from Mike says, those flats are difficult for some customers to deal with. Have you considered offering a keyed motor shaft? And this question is specifically, making a plug to do it as a standard. But, in terms of just customs, I believe we have done keys on step motors before, for keyed shafts.
Yes, we have. Actually, the key is standard on some of our largest size 34 motors, simply because you're dealing with so much torque. Mm-hmm. They're also standard on all of our servo motors. And we can do them on any motor. We can even prototype on our CNC mill right here in California. So yeah, no problem on that. We do run into applications either where you're dealing with a lot of torque or you need a positive lock. We've got an oil and gas application we're working on where we're opening and closing a valve. And if that motor ever gets misaligned with the valve, it's going to be like a New Horizons level bad. So yeah, we do keyways on demand. We also do smooth shafts. Some people don't like flats simply because they're inconvenient for mounting, and they actually just want to drive a set screw right into a smooth feature of the shaft. And yeah, if you want a smooth shaft, we can do that.
Great. Here's a question from Alexis. Do you have some requirements in order to build a custom product? So, in terms of quantities or technical requirements, and I realize this has a little bit to do with commercial decisions and sales, but, are there certain things you look for when evaluating a project for a custom solution?
Yeah, we really do. We always try to do what we can with something off the shelf. That way we don't get into tooling or non-recurring engineering issues, and you can get up and running more quickly pulling something off the shelf. But no, we can work in many ways, and some aspects that you might not have thought of is, for example, private label. Okay, if you want your label on a product instead of ours, we're going to have to design the label, and we're going to have to buy whatever is the minimum quantity, certainly hundreds of them. So we would typically charge a non-recurring engineering fee on that. If you want your drive cover to be a different color and that cover is plastic, we are going to have to buy some pellets and shoot a minimum run of those. That's going to cost something. If it's a metal cover and you wanted a different color, we powder coat all our metal. So we're going to have to buy a 55-gallon drum of whatever powder we're going to spray on this thing. And again, there is some incurred costs there. But we can work with you on the commercial aspects of that kind of thing.
That makes sense. So if there's no upfront cost for us, then it's just the time and energy to develop the code or make some changes. But if we have to get new tooling or buy a lot of raw materials to get something done, of course, we're going to be working with the customer to help cover those costs.
Yeah, that's right.
Great. Okay. This one comes from, I think, a slide where you were showing the 8-axis board from Dave. Is there a limit to how many drives you can put on one board?
Not really. There are some practical limits. For example, if one of the drives were to fail for some reason, how many drives do you want to pull off the machine and replace at once? But certainly more than 8 could be done. Yeah, in this case, 8 was a good unit for this customer because not all of their machines take the same number of drives.
Yeah, and I would imagine some of it, I mean, how many you can fit in a given area is going to depend a little bit on how much current, how big the FETs have to be, how much current you need or heat you need to dissipate, etc.
Yeah, thermal dissipation is a real issue when you put a lot of drives together.
Yeah. Okay, and then this last one from Paul, this is based on the Ethernet IP customization for I think the bagger machine you mentioned. How do you implement the customizations in the Ethernet IP protocol? Is it still compatible with the Allen Bradley PLC?
Oh, absolutely. It has to be. We're not getting anywhere. You will lose your ODVA certification if we tweak one of these, unless you want to fund us to go back to the ODVA and have your version certified, which we'll do if that's important to you. I find certification is more important in a standard product where a lot of different people are buying it and they all want to be assured that this has been looked at by somebody other than us. For customs, it's typically more like if it works, it works, in our application. So how do we go about this? One way we can do it to assure backward compatibility is we can just create a different instance of the assembly, like 100, 101, 102, they all get an address number. So you can have multiple assemblies coexisting in one drive. And in fact, we actually do. Our original implementation of Ethernet IP had a different input assembly than we decided to go with after we had some market experience and realized what was a better way to go. They're both still in there. So if you want to buy a drive today and not reprogram your PLC because you were using us 8 years ago, it'll drop right in and work. You won't even know the difference. But if you're writing new code, you would want to access the new input assembly. So yeah, lots of ways of getting this stuff to be copacetic.
Awesome. Let's see. Okay, so we're running out of time. There are a couple of questions that I think we could better answer via email. So I will call it there on the Q&A session. As I mentioned earlier, if you for those that didn't get their question answered, we'll follow up via email. There will also be a follow-up email sent to everyone on the presentation today with a short 3-question survey about today's webinar. It only takes a minute or two to complete, so please take a moment to click on the survey, submit your feedback. We really do appreciate that feedback, and we really do take it to heart when planning and building our presentations. As a reminder, the final webinar in this 2020 series is 2 weeks from today on July 23rd. And as Jeff mentioned, we'll be talking about linear actuators built around our step servo closed loop stepper motors. So if you're doing any linear motion, you want to check that out. So thank you again, everyone, for attending. We greatly appreciate your interest in Applied Motion products, and have an excellent rest of your day.